This is where we left. Sometimes what is happening, what can be done is that you need to change the magnetization direction. Sometimes we need to change the magnetization direction of only one layer. What will it do? In that case, we will need a small value of some external magnetic field. Or if you need both, you need large amount of magnetic field. So by changing the direction of the magnetic field, actually, you can change the resistance values of this device. And that is how this arrow is actually on both sides. You can change its direction in the same of that above arrow of this much, this arrow. You can use this arrow can be changed in direction of this arrow or opposite to that direction. That's why it has two arrows and it is a single. This is, you mean it is fixed actually there. So this has been because of that antiferromagnetic layer. There's an antiferromagnetic layer of above this magnetic layer, and this antiferromagnetic layer will try to align this layer in a particular direction, in only one direction. And this type of sensor actually, it has been named as it has been named by MRX1518H and series sensor. It is made by a company that is called as NSM Inc., which is in Japan. So they have made this sensor actually. And there's an iron nickel magnetic layer, and its resistance varies by changing the external magnetic field, and the value can go up to 200% here. Sorry, resistance variation, sorry, not 200. In this case, the variation is 3% of the original one. And this 3%, they can detect this 3% change actually. There are another one, I missed, I have not shown that them here, which have been made in USA and by other companies as well. And they detect actually the change in the electrical current, because once you measure the electric resistance, it is an electric current which you are measuring actually. And what are the applications? I will give you a single application here, one of the applications. There are a lot more I can send you. And MR sensor applications. There are a lot of, for example, in disk drives. Disk drives means CD, DVD, or those compact discs, and those cassette recorders which were earlier in the market. And there's an automatic engines. There's a transmission system, vehicle traction, stability controls. There are a lot of where it can be used, and one of them is magnetic recording system. Let me show you a single one. Is magnetic recording system. Here the magnetic recording system is shown. If you have the notes with you on your phone, or you can see it there, and I will try to draw it, but it's not possible for me to draw it clean and neat. Here is a track of disk actually. It's a disk part of that disk, and it has magnetic domains. Sorry. These are different magnets, and the thickness is, it has been made and it is available in the market, and it has 14 nanometers. Remember that those layers, those different layers, ferromagnetic layer and a metallic layer, their thickness is of the order of nanometers. If it has a direction in this, and here it has this direction. These are the direction of those magnetic moments, or the magnetic domains in that magnetic reed head. You have a sensor here, GMR reed sensor. This is a sensor here. It is made and there is some element, actually writing element. What this writing element actually do, I can draw it here. This is a recorded media. Some information is recorded in it. How you read about actually from this recorded media, you have that magnetic tape, some information is recorded in it, and you have a sensor. The sensor is here, actually it's moving. This tape is moving because that magnetic tape is actually continuously moving. You are fixing the sensor, or in some cases the sensor is moving and you are fixing that recorded disk. This is inductive actually here, so it moves those elements actually in this, and there's a gap here between this and this. There's a 10 nanometer gap actually, like this. The magnetic field lines are coming like this, and if you see this part, this part, it is shown there. It is like this. These are two different domains actually. These are different directions. These are different directions of those domains. And this is motion, direction. Now see here, this inductive element which I have shown here, it alters the direction of this magnetic moment, these magnets which are coming through this recorded media. When it alters, and this has a fixed direction, this sensor has a fixed direction, and it can sense only the one component. It can sense the, for example, it can sense the up component, spin up component, and wherever it finds that spin up component, the signal will change, signal will increase, and that signal is then taken to another system that system will amplify. So you have a particular magnetic moment wherever any problem, question की problem?
Yes sir, share screen गायब हो गया.
Share screen गायब हो गया?
Yes sir.
Oh sorry, is it okay?
Yes sir.
Okay.
आ गया.
कितनी देर से गायब था? अभी जस्ट हुआ कि पहले हुआ था?
Sir, just.
Okay, then it's okay. So this magnetic recording, actually what will this do? This will keep them in a particular direct in the aligned plane, and they may have different orientations, but and this sensor has a fixed orientation. So whenever there is a change in the orientation of the incoming moment, spin moment, this GMR sensor will sense that change, and that change is then sent to another this transducer system, which will convert that into an audio or a video, whatever the requirement is. This is how a simple magnetic recorder actually works. There's a lot more details you can find on the internet, but this is the simplest one, and it can sense the change of the order of 10 gigahertz, of the order of gigahertz. That means if these moments change their orientation of the order of in gigahertz frequency, that means within 1 second there is coming a different orientation of the spins, and there is a lot of change. It is up down of the order of 10 to power those 8 or 10 to power gigahertz. I think 10 to power 8, I don't know, please check this. That means it is this much of the fast change the GMR sensor can detect in that recording media. And then there is another one which is Hall. So I will keep it up to here. Please go through this again at your home. I have shown the examples, and this width is actually 30 nanometers here. This is 30 nanometer. Sam, this is 30, this is 30, this. So it is there. And it has a direction, this direction. You can change the direction actually. It depends upon if you remember those cassette recorders, or if you see, if you have ever seen that CD drive, CD compact disc or a DVD, how it rotates, how fast it rotates. And those sensors are those small tips. Those tips has of the dimensions of the nanometers. Those detect any change in that disk actually, which is kept on the top of that disk in that DVD writer or a CD writer, or even the hard disks today, which are in your laptops. Those hard disks are circular inside, just moving continuously, and there's a small tip above it which senses that magnetic moments in that disk, which is rotating at very high speed of the order of gigahertz. So this is how these magnetic recording sensors actually work. And there are a lot more examples in this, and you can check. I can send you the material if you wish. I will send it later on. And Hall sensor we will discuss in the next lecture. And till then, if you have any question, please let me know. Okay, so I will leave here.